Welcome back to Nick Does Maths with me, Nick, here doing some maths for you. We are going to do some roots of polynomials today. We've got a cubic, z cubed plus 2z squared plus k equals 0, and it has roots alpha, beta, gamma. We're going to show some things. Basically, we're going to play around with alpha to the n, beta to the n, gamma to the n. So, we need to show that alpha squared plus beta squared plus gamma squared is 4. That alpha cubed plus beta cubed plus gamma cubed is minus 8 minus 3k. We're told something about alpha to the 4, beta to the 4, etc. And we'll finish that off. There's a couple of cool things we can do here, specifically because it is a cubic. And let's have a look. So number one is fairly standard, but let's get our relationships right. So we know that alpha, beta, gamma is minus k. We know that alpha beta plus alpha gamma plus beta gamma is 0. And we know that alpha plus beta plus gamma is minus 2. Right, so these are our starting 3, and we're going to work from there. Now, classic alpha plus beta plus gamma, we're going to go alpha plus beta plus gamma all squared, because that is alpha squared plus beta squared plus gamma squared plus twice the double products. Now that is 4 is alpha squared plus beta squared plus gamma squared plus 0. So we have shown what we wanted to do here. Right, number 2. Now I'm going to show you a couple of ways to do this. Alpha cubed plus beta cubed plus gamma cubed. Now, once we've got this one, what I'm going to do is I'm going to look at alpha plus beta plus gamma times alpha squared plus beta squared plus gamma squared. Now, this is perhaps the clunkier way to do it. So what do we end up with? If we expand this out, again, alpha cubed, a beta cubed, and a gamma cubed. And I'm going to get an alpha squared beta and an alpha beta squared. I'm going to get an alpha squared gamma, an alpha gamma squared, and a beta squared gamma, and a beta gamma squared. Now here's the trick. What I'm going to want to do for each of these is I can add on an alpha beta gamma to all of them. I'm going to add on an alpha beta gamma to all of them, and then I have to remove 3 alpha beta gamma, because then the blue and the red stuff cancels out. Why is that? Well, these terms here, all of them, you could factorize out. So from this one, we're going to factorize out alpha beta. This one will factorize out an alpha gamma, this one a beta gamma, and we end up with this idea here. Alpha plus beta plus gamma times alpha squared plus beta squared plus gamma squared is equal to alpha cubed plus beta cubed plus gamma cubed plus, that is an alpha plus beta plus gamma times the double products minus 3 times alpha beta gamma. And we can play with that, and we can get everything we need out of that. Okay? Now, that ain't fun. That is not fun. Right? I end up with, what do I end up with? Let's get this out, because we are running low on space. Alpha plus beta plus gamma we said was minus 2. Alpha squared plus beta squared plus gamma squared we said was 4. Alpha plus beta plus gamma becomes a minus 2. This is 0. And all of that multiplied together is minus k. And in fact, you do end up with the correct answer if you reorganize that. Alpha cubed plus beta cubed plus gamma cubed is equal to minus 8 minus 3k. That is not fun, right? And I can already see the writing on the wall, because we're going to be told something about alpha plus beta plus gamma, therefore find k. alpha to the 4, beta to the 4, gamma to the 4. And we're going to have to do something similar with alpha to the 5, beta to the 5, gamma to the 5. So what I quite like is something a little bit nicer than this, but this is a way we can do it. So let's undo all of that. Rewind. Right. So instead, what are we going to do? Well, we know that alpha, beta, and gamma are solutions to that. So if we plug them in, that's alpha cubed plus 2 alpha squared plus k equals 0. It's beta cubed plus 2 beta squared plus k equals 0. And it's gamma cubed plus 2 beta squared plus k equals 0. And if I add all of these, I will get the fact that alpha cubed plus beta cubed plus gamma cubed, that's a gamma in here, isn't it? Plus 2 times alpha squared plus beta squared plus gamma squared plus 3k is 0, which gives me our result. Because we know that that is 4, and we are done. Much nicer way to do it. So a cool one to do, and like we can't do it here because we've got the cubes going on, but we can for this one. Now, if we are told that alpha to the 4, now how are we going to do this with alpha to the 4, etc.? So what I'm going to do is I am going to, again, clear up a bit of space and add this up here. So we know that alpha squared plus beta squared plus gamma squared is 4. Right, so that's the idea. Now what we're going to do is this. What I can do is actually use the fact then, if I multiply all of this by z now, I get z to the 4 plus 2z cubed plus kz is equal to 0. And we can do the same trick. Alpha to the 4 plus 2 alpha cubed plus k alpha equals 0. Beta to the 4 plus 2 beta cubed plus k beta equals 0. And gamma to the 4 plus 2 gamma cubed plus k gamma equals 0. So if we add all of these, we will get alpha to the 4 plus beta to the 4 plus gamma to the 4 plus twice the sum of the cubes, and then k times the sum. Right, so let's plug all of that in. We know that that is 8, the sum of that, and that is minus 8 minus 3k. Then alpha plus beta plus gamma is minus 2, minus 2k is 0. Right, so let's multiply that out. I get 8 minus 16 is minus 8. Minus 6 minus 2 is minus 8k. That is 8k. Therefore, k is minus 1. Bottom. Isn't that nice? And let's do the last one. Now, to do the last one, you may or may not be surprised to figure out that what we are going to do is I'm going to multiply my original equation through by z squared. So that becomes a 5, that becomes a 4, that becomes a squared. 5, 5, 4, 4, squared, squared. So bum, 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 bum. So 5, 5, 5, 4, 4, 4, squared, squared, squared. All right. So we are left with the fact that alpha to the 5 plus beta to the 5 plus gamma to the 5 plus 16. We know that k is minus 1. The sum of the squares is 4. That should work. Yes. So alpha to the 5 plus beta to the 5 plus gamma to the 5 is negative 12. Skudum. Really like this question, and it brings us some of these ideas. Now, you could play around with that and that by doing a similar thing to what I first tried with the alpha cubed plus beta cubed plus gamma cubed. Take the previous one, multiply it up, see how you can fudge it. It ain't fun. It is not fun. Whereas taking this idea, well, how about I just plug the roots into my original equation and see what I can do with that? Kind of funky, one to look out for when we're playing with polynomials. Obviously, you're a little bit tied up that you can't use it until you get to cubed. Still very, very cool. All right, I hope you found this interesting, you enjoyed it. Don't forget to like, subscribe, hit the notification button, drop us a comment, let us know how you're finding our more long-form videos here on YouTube and how is that helping you for your further math studies. I'm Nick here at Nick Does Maths. I hope to see you again soon for more cool and fun stuff here as I slowly lose my mind. I will see you there. Toodles!